Let's start our discussion of fraction operations by looking at adding and subtracting rational numbers. Now we're going to look at a simple problem first, something like 1/4 plus 1/4, and think about the meaning of those fractions and what addition really is. If we have 1/4, that means out of one whole, in this case the one whole is the one whole circle, we are going to be counting one of the four equal parts. So that would be the blue shaded in part of this circle. We add to that one more fourth. And we can see that we have 2/4 shaded in. We can also see that those 2/4 are equivalent to 1/2. We've already talked about equivalent fractions, but you can see how using a model like this also shows that sometimes when we add fractions, we do have a fraction that can be simplified. Adding fractions gets a little bit trickier when we have fractions that do not have like denominators. So let's think about what could happen if a student adds these fractions incorrectly. A student might think you simply add the numerators and add the denominators to get a sum of 2/7. Well, let's think about that. 1/4 is 1 out of 4 equal pieces of a whole, and 1/3 is 1 out of 3 equal pieces of a whole. So what's wrong with saying 2/7? When I look at the picture, I see 7 pieces, and I see that 2 of the 7 pieces are shaded in. What could be wrong with 2/7? Well, there's a couple of things wrong with this. First of all, the pieces that we're looking at aren't the same size. How can they all be 7ths if they are different sized pieces? And if you think about what that denominator of 7 means, 7 as a denominator means that one whole is divided into 7 equal pieces. And we don't have 7 pieces in a whole. We have 4 pieces in one whole and 3 pieces in another whole. So 1/4 plus 1/3 equals 2/7 definitely is not correct. So let's look at the right way to do this problem. If we're trying to add 1/4 and 1/3, that means we have 1 out of 4 equal pieces of a whole that we're adding to 1 out of 3 equal pieces of a whole. If you think about the set model for addition that we've already used for whole numbers, we can extend that to look at what happens with fractions. If we take the 1/4 and the 1/3 and combine them into a single set, we would have something that looks like this. Now, another common student mistake would be to look at that model and say, well, there's 3 pieces there and 2 of them are shaded, so that must be 2/3. And that wouldn't be correct either, because even though we do have 3 pieces in this whole, they aren't equal pieces, so they can't be thirds. So what does have to happen? We need equal pieces. Well, the way we're going to get equal pieces is by taking that whole and dividing it up into smaller pieces, smaller equal-sized pieces. So what we've done is we've taken the 1/4 and we've divided it into 3 more pieces, and we've taken the 1/3 and divided it into 4 more pieces, which means the whole has 12 equal pieces in it now. So what has to happen with the numeric fractions to make that work? Well, the 1/4 can be written as an equivalent fraction with 12 in a denominator by multiplying numerator and denominator of the fraction by 3. Remember, that means we're really multiplying that fraction 1/4 by the number 1, because 3/3 is equal to 1. We haven't changed the value of the fraction. And the same thing can be done with the second fraction if we multiply numerator and denominator by 4. So now what we have is 2 equivalent fractions to what we started with, but they have the same denominator. So we're looking at adding pieces that are the same size. So if we add 3/12 to 4 more 12ths, we have 7/12, and you can pretty clearly see in the model that that's exactly what's happening. Now let's look at this same problem with a model that also shows area, and we're going to use rectangles this time. So let's think about the 1/4. The whole in this case is a whole rectangle. So if this whole rectangle is divided into 4 equal pieces and we shade one of those 4 equal pieces, we're representing 1/4. And the other rectangle represents a whole, and we're going to divide it into 3 equal pieces and shade one of the 3 equal pieces. Now obviously those pieces are not the same size, so we need to subdivide the first rectangle so that we have 12 equal pieces, and the second rectangle so that we also have 12 equal pieces. And now what we've got is pieces inside each rectangle that represent twelfths. We have 4 twelfths in the bottom picture and 3 twelfths in the picture above that. So 3 of those green twelfths plus 4 of those yellow twelfths is 7 twelfths in all. Now remember, with mixed numbers there's an implied addition going on. So when we see 1 2/3, that really means 1 plus 2/3. And when we see 2 3/4, that really means 2 plus 3/4. So we're going to keep that in mind as we look at how to add these mixed numbers together. If we look at a model for each of these numbers, 1 2/3 would be 1 whole plus 2/3 of a whole. And 2 3/4 would be 2 wholes plus 3/4 of another whole. Now certainly if we look just at the wholes, we can add the 1 whole and the 2 wholes together to see that we have 3 wholes. But what do we do with the fractions? Well, with the fractional parts, we have to find a common denominator. We have to break these up into equal-sized pieces. So we will write each of the fractions as a fractional part of 12 equal pieces. So 2/3 is the same thing as 8 twelfths, and 3/4 is the same thing as 9 twelfths. So now we can see that we have the 1 whole and the 2 wholes, which add up to 3 wholes, and the 8 twelfths and the 9 twelfths, which add to give us 17 twelfths. Now since 17 twelfths is an improper fraction, we can do some regrouping. The 17 twelfths could be regrouped into 1 whole and 5 twelfths of a whole. And the 1 whole can be combined with the 3 wholes we have already to give us 4 wholes. So we have 4 and 5 twelfths. Let's look at a different way to do that same problem. We could take each of the mixed numbers and write them as improper fractions. So 1 2/3 is the same thing as 5/3, and 2 3/4 is the same thing as 11/4. We would still need to have equal-sized pieces, so we could rewrite the 5/3 as 20 twelfths and the 11/4 as 33 twelfths. So now if we add 20 twelfths and 33 twelfths, we have equal-sized pieces, so we have 53 of those twelfths. And since we started with mixed numbers, let's end with mixed numbers. 53 twelfths as an improper fraction is equivalent to 4 and 5 twelfths as a mixed number. Now when we're subtracting rational numbers, we have to make sure that we have common denominators as well. And that's for the same reason as addition. In order to do an addition or a subtraction, we have to make sure that the pieces that we're working with, the fractional pieces, are equal-sized pieces of a whole. So the least common denominator when we have ninths and twelfths would be 36. We'll multiply the first fraction times 4 over 4, and we'll multiply the second fraction times 3 over 3. Remember, in both cases, the reason we can do that is we're really multiplying by a number that's equal to 1. 4/4 is 1, 3/3 is 1. That gives us two fractions that have the same denominators, 8/36 and 3/36. So now that we have equal-sized pieces, we can subtract 836 minus 336 is 536. Let's try 2/5 minus 1/2. Our common denominator, our least common denominator, is 10. So if we multiply the first fraction times 2 over 2 and the second fraction times 5 over 5, we'll have fractions that have the same denominator. So we have like fractions. So if we have 4/10 and we take away 5/10, we're left with -1/10. Now you'll notice that that negative sign in this case is sitting up in the numerator of the fraction. We could also write that fraction as having the negative sign out in front of the entire fraction and just have the numerator say 1. So we could have a negative in front of the whole fraction and then have it say -1/10. If we're subtracting mixed numbers, we also have two ways to look at the problem. One is to say that we're going to subtract the fractional parts and we're going to subtract the whole number parts. We have to be a little bit careful about subtracting the fractional parts because we need a common denominator to do that. So our least common denominator would be 15, and we can rewrite the problem as 4 3/15 minus 1 10/15. If you look at the fractional parts, if we try to take 10/15 away from 3/15, we've got a problem. We don't have enough 15ths to take away. So we're going to do a little bit of regrouping. Now think about the models that we looked at with the circles. Imagine that we have 4 whole circles and 3/15 of a circle. We're going to take one of those 4 whole circles and break it up into smaller parts. That would leave us with 3 whole circles, but the one whole circle that got broken up into smaller parts was broken up into 15 equal parts, which meant we would have 15 15ths plus the 3/15 we already had, which would give us 18 15ths in all. Now we can subtract. 18 15ths minus 10 15ths is 8 15ths, and 3 minus 1 is 2. So our difference is 2 8 15ths. Another way to do that problem is to rewrite each fraction as an improper fraction. We still would need a common denominator to subtract. That common denominator is still 15. We now have 63 15ths minus 25 15ths, which is 38 15ths. And to rewrite that as a mixed number, we could take 38 and divide it by 15. So 2 8 15ths is our difference. So that's a quick look at some fraction operations, addition and subtraction. It's important that you be able to not only do the fraction operations, but that you really understand why we need to find those common denominators, why it's important that the pieces that we're working with have to be the same size before we add or subtract them.